compound splice and RiskVary. Okay, so RiskVary is a distribution that you enter in your model. It's, let's say, very simple and very versatile, because it allows you to, so you can see here, as I have referred the base value to the cell A2, the low range in A2, sorry, the base value is B2, low range in A2, and high range in C2. So you feed those values to the distribution, okay? So that would be more or less the parameter table. And then you can specify if you want this vary function to be a triangular, a distribution, trigen, normal, or pair distribution. So these are the four elements supported. And you can indicate percentages or actual values, right? So for example, if I choose actual values, like here, my distribution will sample from 90 to 110, okay, in increments. So this is a very easy way to introduce uncertainty in a model over a number of variables. You want to see how your bottom line changes, for example, by entering a vary distribution. You choose a triangular, or you choose a uniform distribution, and then you can sample very quickly and create a stochastic model, let's say from very little knowledge. Okay, this would be for a quick appraisal of the model. The next distribution would be the Risk Splice. Risk Splice is really a distribution that has been tweaked, changed to adapt what could be a good distribution on most of the distribution, but we want to replace, for example, the tail, as you will see in the example, with another distribution that may be more suitable. For example, here, the way it works is that I have to introduce the function Risk Splice F3, F4. F3 is a log normal distribution, so that would be the main body of the distribution. M4 would be an inverse Gauss distribution, and the 7 here is the splice point. So 7 would be the cutoff point at which I will link or splice both distributions. I click on the distribution function there, and that's my Risk Splice. I don't know if you can see it on the screen, hopefully you can. But the splice point here, you can see that, I mean, we have put a marker that there is like some kind of a step in the distribution, right? So it's not a natural log normal. I can use this fantastic feature of which is the overlay feature that you can use in any distribution, by the way. For example, you can compare a triangular distribution with a pair distribution using the overlay. You can use the overlay to see more clearly this. So for example, the first part of the distribution, we said it was a log normal distribution. So we're gonna add an overlay. We're gonna use some favorites. See if it's here. Okay, so we're gonna choose a log normal distribution. I can type the L and go directly there. So I pick up my log normal distribution, and then I enter the parameters that best fit the shape for 1. Okay, so you can see here that at the splice point, we have, you follow the red line. The red line has a much shorter tail, right? But because we have spliced it with an inverse Gauss, that allows us to sample a much longer tail of a distribution. So what you are doing really is creating like a